Okay, hey everybody. Today we are in the Leetcode 30-day challenge and we have a very good problem today, and that's its name is leftmost column with at least a 1. So this problem is interactive problem, and we will not be given a direct matrix as they have told us. Let's go into the problem first. A binary matrix means that all elements are 0 and 1. For each individual row of the matrix, this row is sorted in non-decreasing order, that means ascending order basically, and return leftmost column index with at least a 1 in it. If such index doesn't exist, return -1. So what we need to do is we have to return the leftmost column index with at least a 1 in it. Okay, so and the speciality in this problem would be that we can't access the binary matrix directly. We have to interact, or we have to access this with the help of an interface. So this is not that much hard, because we just have to access, we will have to get everything by calling these functions. These dimension functions will give us the size of the matrix, and this dot get will be used to access the value at the index. Okay, so we will be doing this. And what else? Mission making more than 1000 calls to binary matrix dot get will be judged wrong answer. So this will take count of the time complexity. I think that is why they have mentioned it. Okay, for time complexity bound they have written this 1000 calls. And so what hints do we get by reading this problem? The first most, and that's the most important hint, is that the row is sorted. So it will for sure include binary search. Let's just quickly take the example. So suppose this is the example. So we can see that the output is 0. That is because the leftmost one is in this column. Okay, so its column number is 0, so output is 0. In example 2, we can see that the leftmost one is occurred at the first column, so output is first, and in third there is no one, so the output should be -1. And in this example, you can see that first one is encountered at the first index, so this is our answer. So how we will be doing it? Let's just quickly see the explanation part, and then we'll code it out. So let's jump onto the explanation part first. Suppose this is the matrix given to us that we will be accessing with the help of the given functions. So how are we going to solve this? The biggest hint that was given in the problem was that the rows are sorted. So whenever we hear this sorted term, the first thing that should come into our mind is binary search, and that is what we'll be implementing in this question. If you look at each row, so each row is sorted. Okay, so what I will do, I will first apply binary search on the first row, and that binary search will give me the index of the first one that I encountered. Okay, so on each row I will apply binary search, and since the row is sorted, so from any row where I will get the 1 as the minimum, so that will be our answer, because there are only two elements, 0 and 1. Okay, so where in whichever row I'll get the index of 1 as the minimum, that will be our answer. So if you look at this case, after applying binary search on the first row, I will get output as 0 1 2 3. Okay, 3 from here. And after applying binary search on the second row, what I will get, the first one is at index 2, so it will return 2. So since 2 is less than 3, so I will update my answer and I will store 2 in it. Okay, and similarly when I will apply binary search on the third row, it will give me the index of this first one that is encountered. So it is encountered at the first column, so it will give me the index of this first. Okay, so that is our approach. Okay, so I'll just simply tell how binary search will be implemented on the first row, and then we'll code. So suppose this is the array given. So low will be 0 and high is the third index. So in the binary search, what we do, we define a mid that is equals to low plus high by 2. Okay, so low plus high by 2, low is 0 and high is 3, so 0 plus 3 by 2, that will be equal to 1. Okay, so initially it will be at index 1. So here will be our mid. So what we will check, if the middle element is equals to 1. Okay, so if our middle element is 1, we will assign our high as mid. Okay, this you can visualize. Suppose that if this would have been the array, so suppose if middle is here. Okay, so if we encounter it as 1, then that means that first one is to the left of it. So we need to set our high as this, so that we can search from here to here. We need to find the leftmost one. That is why I am assigning high as mid, and I'll take a pointer, I'll take a variable as count, and I'll increment it so that I know that I have encountered a 1. Okay, this will be helpful when we will consider the final answer. Basically just for identifying that I have encountered 1. Okay, or else if I have encountered 0, then what will I do? I'll simply assign low as mid plus 1. Okay, so in this case, if you see, our mid was here at this index, so it is not 1. Okay, so we'll go in the else part, we'll set low as mid plus 1. So our low will be here now. Okay, and our high was here. So now you again count high plus low by 2, mid will be equal to low plus high by 2, 2 plus 3 by 2, and that will come out to be at the second index. So at second index you can see again it is 0, so again low will be mid plus 1. Okay, low will be mid plus 1 and low will come at 3. So low will finally reach here, and now since it is 1, okay, and our mid will be now 3 plus 3 by 2, that is at the third index. So at third index you can see that mid is 1, so high is equals to mid. So just concentrate on this part, that at last the index of 1 will be stored in high. Okay, the high after coming out of the loop, high will contain the index of the leftmost one. So we just need to do this, and we'll do it for each row, and in whichever row I'll get the leftmost one's index the smallest, I'll return that, and that's simple. So now let's just jump onto the coding part. Okay, so let's start coding now. First of all, I'll define a list. Okay, it is just because of the given interface that we are using. We are not given the direct matrix. Okay, you can see here it is written at here the matrix binary matrix dot dimensions returns a list of 2 elements. So for catching the size of the matrix, I'll need to define a list, and in that list only I'll be catching the length of matrix. So how to catch the size is by writing the function dot dimensions. Right, after that I will simply check if either of the height of length or column is 0, then our answer should be -1. So if size dot get So we'll simply return -1. This get 0 will be giving us the n, the row, and get 1 size dot get 1 will give us the column. Okay, and now after that our outer loop for checking each row. So for I equals 0, I must be less than the total number of columns. So columns I'll get from get 0. Okay, so this outer loop will be for the total number of rows, and here I have to take a variable also, that is the answer. Okay, and initially I will assign it the maximum value, because I have to, whenever you have to return the minimum value, initially you will have to assign it the maximum value, so that you can take minimum of it and then get the answer, right? And so high will be the size of columns, and the one that we have to initialize is count also for checking whether we encountered one or not, and low will be the 0th index always. So now here comes the binary search loop for while low is less than high. Okay, inside that middle element, that will be low plus high divided by 2. Okay, and now comes the condition part. So how to access that matrix is by this function, if binaryMatrix dot get, the row is the loop variable I, and the current element is at the column index mid. So if the current element is 1, then that means the first one could be at the left side. Okay, so assigning high the mid value will take us to the left half of the row. Okay, so, and count plus plus, just because I should know that whether this row contains at least a single one or not. That is the purpose of count. So the else part, else if the middle element is 0, then that means the first one is at the right of the middle element. So simply low is mid plus 1. Okay, so this was the binary search method, and after this I will simply check at last if count is greater than 0. Then that means if I encounter at least a single one in the current row, so that means that we will have to update our answer, and that will be minimum of answer comma high. As I have explained that after going out of the loop of binary search, high will contain the index of the leftmost one, so I'll simply take minimum of that, and at last I will return answer, but with the use of a ternary operator. I'll tell you why I'm doing this. So if answer is equals to integer dot max value that I had initialized it earlier, so that means that we never went inside this loop. Okay, so that simply means that in the whole matrix there is not even a single one, so that would simply mean that we have to return -1. Okay, else we'll simply return answer. So this was it. I simply used a binary search, okay, inside this for loop. So its complexity will be simply O of n into log m, because it is n cross m matrix. The outermost loop we are reaching at, we are accessing each row, but in m we have used binary search, so binary search time complexity is log m. So n log m will be the time complexity, and let's just run it now. Running it. Compile error. Okay, spelling of this is okay. What else? Lots of semicolons. Where do I have to put in? Just a second. This is done. This is done. Okay, I guess only this was the error. Let's run it again. Oops. Here is the completion error. Now it should run. Just expected for basic test cases. It's done. Submitted. Okay, so it is submitted, and the time complexity will be O of n into log m, and that was the question.